Hello and welcome to section 4.3 where we're going to discuss proportions and percentages. We're going to practice in class, but before we do, I would like for you to take notes on this so you'll have an idea of what to do for your examples in class. So for the first example, here we have an example where we're trying to find a percentage of a particular number. So 120 is 60% of what number? Anytime I do proportions, I like to set them up in a way that it's going to be percent over 100. So whatever the number that they're working with as the percentage, you just put the number on top and then you put 100 on the bottom, because percents are a portion of 100. So it's a fraction of 100. Then you're going to set it equal to is over of, which means whatever number we're talking about is going to be on top, and then the part that it is part of goes on the bottom. So you'll see what I'm talking about with this example. So notice how we have 60% in the problem. So 60% is going to be represented with 60 over 100. Then you're going to set that equal to 120, because 120 is, okay, so that's the part that's is. And notice how it says of what number. So the of is the unknown number that we need to find. So this would be the appropriate way to set up your proportion. Then we're going to cross multiply. So if you want to cross multiply, you end up getting, well, not even cross multiply. We could just use the method that we used in class, where whatever you have over here, you could multiply a nice number to get the number that's on top as well. So 60 times 2 is 120, and if you multiply by the same number to 100, you should get whatever x is. So we can use this method in order to solve this proportion. So now you end up getting 100 times 2 is 200. You can also check yourself by actually finding 60% of 200 to see if you get 120. So 200 times 60%, so percents, you know, you have to change percents to a decimal by moving the decimal 2 places back to the left. So that's how I ended up getting 0.6. So if you multiply 200 times 0.6, you get 120. So that is like a little check to make sure that we did our problem correctly. You can also do cross multiplication, but in this case I thought that was the easiest way to handle that question. Okay, let's try this one. If 3 of every 8 individuals in a population carry the gene of a defective enzyme, what is the ratio of individuals who carry the normal gene? So for this problem, we're given 3 of every 8. So the ones that carry the gene, the defective gene, would be 3 over 8 if I wanted to write that in a fraction. Now everyone else would be considered having the normal gene, carrying this normal gene. So the ratio is going to be, you can call it the complement, or you can just say the rest of the 8. So you can think 8 of 8 being all, okay? So, which is also considered 1. So you could just say 1 minus 3 over 8 to get the rest, or the normal. So to get the normal, you could just say 8 over 8 minus 3 over 8, and that will give you 5 over 8. So this is the answer that we are looking for here. Trying to highlight it, but I guess it doesn't want to work. Okay, so this would be your final answer. Okay, next example. Here, there are 500 male and female participants in a 10K race. If 52% of race participants are female, what is the ratio of female to male participants? Now, it's very important to pay attention to this female to male order with the ratio, because that means the first number is going to be female, the second number is going to be male. So if we know the total here is 500, then we want to go ahead and find the percentage that are female. So the percentage that are female, it's going to be 500 times. Now you remember what we did with the other number. If we want, I'll make this a little bit bigger. If we want this number 52 to be a decimal, we just take the understood decimal behind the number and move it 2 places to the left. So 52% becomes 0.52 as a decimal. When you find 52% of 500, you end up getting 260. So that's the number of females. In order to find the number of males, you could either find 48%, which would be the rest of the 500, or you could find it as the difference from 500. We know we have 260 males, 260 females, so we're going to find the males by subtracting females from the males. And this gives you 240 males. So the ratio from female to male is going to be 260 to 240. As you notice, these numbers are both even. Looks like they're both divisible by 20. So if you divide 20 with both of those numbers, and then you end up getting 13 to 12. So for every 13 females, there are 12 males. So this will be the reduced ratio. So for example 4, and this is our final example for 4.3, suppose there are 500 animals in a zoo, and 42 of them are herbivores. How many of them are not herbivores? So similar to our male-female example with example 3, you're going to take the 500, find 42% of them, and those will be your herbivores. So for the herbivores, I'm just going to say herb and not herb. So for the herbivores, we're going to take 42% of 500, and you end up getting 210. And for the non-herbivores, you're going to take 500 and subtract the herbivores, and you get 290. So here the question is not asking for a ratio, but they're just asking for how many. So the answer would just be 290, I guess you could say non-herbivores would be the final answer. So whenever you have questions that are, let me do better, y'all. Okay, so anytime you're being asked questions on especially application problems, make sure you give me a unit. Also, box your answer if there's work to be shown. And that's pretty much it. So if you have any questions, please let me know, and I'll be glad to do more examples. Have a great day.